Hello everyone, this is Professor Chan for Math 1245 speaking. Today we're going to be continuing on with section 2.5, which is transformations. We're going to be learning how to do transformations of entire graphs this time, as opposed to just points. Now before we begin, I do want to inform you about just the assignments you'll be doing. In the homework, a lot of times they would ask you just multiple choice questions, or they'll show you pictures of the transformed graphs. Now, what I want to share with you is that knowledge is not going to be enough. You need to make sure you know how to do it by hand and do the visualization by showing your work. And that's what I'm going to show you today. Okay, so do pay attention because it's going to be important to you, because this may be given to you. You may be asked this on the test, or you may be asked this in some of your concept checks as well. So let's get started. So remember that every single transform graph is going to be a offshoot of your parent graph. So let me show you this right here. I have a parent graph of square root of x, right? My first problem is negative square root of x. I immediately should realize this is an offshoot of square root of x. Okay, so let's look at this here. So before I start, one thing I'm going to do is I want to look at what my parent graph is, which is square root of x. Okay, and I want to graph I want to start off with all of my points that I know would fall into square root of x. I haven't done anything yet to it. Okay, so make sure you know your specific points for square root of x. Okay, what you can do is use your calculator first, right? And I can graph square root of x. Okay, so I graph it, looks like this. I just want to know specific points. Okay, so obviously 0, 1, 4, 2, 9, 3 would work. So I'm going to show this to you. This is going to be 0, 0, 1, 1, 4, 2, and 9, 3. Those are some of my points, okay? Remember, make sure you remember your domain and range of your parent graphs. Okay, that's what's going to help you. And the more that we're going to do this, the more you're going to know some of your original points for specific parent graphs. So what I'm going to do is I'm going to see what transformations I'm doing. So I realize that I'm going to be doing negative square root of x. So the negative square root of x here, right, what does that mean? Okay, remember, this is going to be a flip across the y-axis, right? So this is a flip. Remember, and then not only do you remember the transformations, you want to understand what the operation is. So since I'm doing a flip across the x-axis, that means I'm multiplying y by -1. So it's going to be, my x's are going to be the same, but all my y coordinates is going to be flipped upside down or multiplied by -1. So it's 0, -1, -2, and -3. And then we can sketch. So I have 0, 0, 1, -1, 4, -2, and 9, -3. So it looks like this. Okay. So once you're done with all your transformations, this is the points you'll use to graph your function here. Okay. So let's do another example here. Let's do x squared minus 3. So I want to know what my parent graph is. My parent graph is x squared so this is going to be x squared minus 3. So We'll start off with x squared. Let's talk about what specific points we'll use. So I'm going to use these 5 points. I'm going to do -2, -1, 0, 1, 2. -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. So then I'm going to do x squared minus 3. What does that mean? The -3, if you guys remember, is a vertical shift down. So that means, right? So that means I'm going down by 3, right? So that means my y, I'm subtracting 3. So this will be -2, 1, -1, -2, 0, -3, 1, -2, and 2, 1. So I have 0, -3, 1, -2, and 2, 1. Okay, and it'll look something like this right here. Here's the thing, if you're not sure if you have the correct answer, you can check. Now, I do want to warn you once again, you must show your work. You can't just throw this in your graphing calculator. So, but if you're not sure, check to see if it works. Okay. And it definitely matches, okay, for the following right here. Okay. So you can use it as a check, but once again, I do want to remind you, you must show your mathematical work, right? And how we do that is, right, I'm showing my transformations of my tables, how it changes. Okay. Now, looking at our two examples, one thing I do want to re-emphasize, remember your transform graphs, all they do is they either move my graphs like up, down, left, right, or they flip it, or they stretch it. The thing that you have to remember is that original shape should still be the same, right? So if you remember, square root of x looks like this little curve. Now it can be flipped upside down, but it's still gonna be the semi-curve that it entails. Likewise, if I look at x squared minus 3, right, my parent graph is a parabola. It's going to be a kind of a U shape. And notice it just shifted down, but notice it's still kind of a U shape. Okay, so always remember that your shape will always be preserved, even though if it's moved around. Okay, so I should not be graphing x squared minus 3 and all of a sudden I'm getting a line, or I'm getting a V, or I'm getting a circle, right? It should still be some form of a U. Okay, maybe it might be an upside down U because it's flipped, but should resemble the shape, the parent graph of its parent graph. Okay. So those are two examples right here. Now I want to show you what would happen if I have multiple transformations. So let's look at, for example, number 4. Okay. So number 4, let's take a look at number 4 right here. It's going to be the following, right? So I have 3x minus 2 squared plus 1. So now here's the thing. I have 3 transformations. I have this 3, I have this -2, and this +1. The thing that I want to first realize is, right, I want to realize what is my parent graph. So if you notice, this is essentially an extension of actually x squared still, right? So I still start off and I'm still doing my x and y coordinates, right? So I'm still going to do x squared. I'm going to use, once again, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. Now, the thing is, I have 3 transformations happening. So what I'm going to do is I'm going to kind of list what they are in order. Okay? The trick is you want to think of order of operations. So you can do the following. Okay? You can do it like this. So you can say vertical stretch by 3, going to the right by 2, and then going up by 1. Okay? So the way we think about this is stretches go before flips. Sorry, stretches and flips goes before shifts. And a way to think about it is multiplication always goes before addition and subtraction. Okay? So I'm going to do each of my situations for the following. So I'm going to do my next table, right? And I'm looking at number 1. So I say vertical stretch by 3. What does that mean? That means I'm multiplying y by 3, right? So my y's get multiplied by 3. My x's stay the same. And I have 12, 3, 0, 3, 12. Okay? The next thing I'm going to do is I'm going to go to the right by 2. So that means I'm adding 2 to x. Okay, you don't need to, here's the thing too, you don't need to like write the whole thing out. You just need to make sure you show what your table is after each change. You don't need to do the +2. I'm just doing it to kind of remind you kind of what the operation is happening. So this becomes 0, 1, 2, 3, 4. Now my y's this time stay the same, right? Because I'm not doing anything to my vertical, right? For the following here. And then lastly, I'm going to do my up by 1. And let's remember, what operation is that? If you remember, that means I'm adding 1 to y. Okay? So here's the thing. When I'm doing each transformation a little bit at a time, and I encourage you guys to do this as well, is that only one of your columns will be changing, right? So either your x column or your y column, but they shouldn't be changing at the same time, right? So notice the first one, I'm changing my y, then I'm changing my x, and then now I'm changing my y again. I'm going to add 1. This is 13, 4, 1, 4, 13. And then we'll graph our results. Okay? So 0, 13, 1, 4, 2, 1, 3, 4. Okay? I'm going to just do a rough approximation, but this is what it looks like right here. Okay? And once again, you can check. So I'm going to do the following. I type this in. Okay, that looks pretty similar. Yep, and we're good. So if you notice, our points match up, okay? For the following. Okay, so we're going to go over and look at another example here. So, number 5 is absolute value, okay? Let's remember what we're going to do with absolute value here. So, my parent graph is absolute value. The ones I'm going to use, right, is, remember it's a V shape, it's symmetric on the y-axis. So I'm going to do -2, -1, 0, 1, 2 as well. Remember, absolute value of all these be turned positive for the following, okay? And remember, if you're not sure what points you use, start off with your graphing calculator of your parent graph and then go to your table. But as the more you practice this, the more that's going to be secondhand to you for the following. So let's take a look at what transformations I have. I have -2 and +3. My order of operations is going to be my flip. That's from the negative. the vertical stretch by 2, and then I'm going to the left by 3, okay? I'm doing order of operations, right? Multiplication must go before addition and subtraction. Now, here's the thing. You could flip 1 and 2 around. That's fine. That's not going to change your result. You cannot, but the thing is, both of them must go before moving to the left by 3, okay? So, let's talk about this, right? So, the first one I'm going to do is I'm going to do my flip. So this is what I'm going to do. Sorry, let me clarify. It's going to be flip across the x-axis. What does that mean? That means I'm going to multiply my y by -1. So -2, -1, 0, -1, -2. -1, 0, 1, 2. I'm going to do my vertical stretch by 2. What does that mean? I'm going to multiply my y's by 2. Okay. And again, all I'm doing is I'm just doing a little bit at a time. Okay, so notice my y is being changed, but my x stays the same. So this will be -4, -2, 0, -2, -4. And then I'm going to the left by 3. So what does that mean? I'm going to subtract 3 from my x. Remember, too, your horizontal shift is always opposite of what you think it is. So, -2 minus 3 is -5, -4, -3, -2, -1, right? All my x's are being subtracted by 3. And then my y stays exactly the same. Now, we're done, so we're going to use these points. So I have -3, 0, -4, 2, and it's going to look like this here. Okay. Okay. And once again, please show your work and how you're doing this for the following. Okay. So I'm going to show you one last example. Okay. And again, if you have questions, please let me know. These can get a little tricky. As you can see, these two take a long time. But the more you practice, the more this will make sense for the following. But again, you must know how to do this by hand. Okay. So I want to do one more example, something like this, okay? So let's take a look at this one right here, okay? Because a lot of these problems, sometimes you'll have some unorthodox like this one, right? This one, you can't put this in your graphing calculator. So this is actually another reason why you must know how to do this by hand. Because this one, you can't actually just throw this in your graphing calculator. Notice you don't have it doesn't have like an f of x equals something. You can't plug it in your graphing calculator. So what are we going to do with this? So this picture above is what's called my parent graph. So I have a new parent graph, but it doesn't give me the actual function of it. So what I'm going to do is like I do the following. I'm like, well, what's my parent graph? My parent graph gives me a 4 points that are from my parent graph. So I'm like, okay, I have -4, -2, -2, -2, 2, 2, and 4, -2. I notice it says draw 2 times f of x plus 3. So I should realize I have two transformations. I have a vertical stretch by 2, and I am going up by 3. Okay, remember, number 1, vertical stretch by 2 must go first. Then the vertical shift up by 3 because multiplication goes before addition. So I'm going to do my first operation. Vertical stretch by 2, that means I'm going to multiply this by 2, my y's. So I have -4, -4, -2, -4, 2, 4, and 4, -4. And then I'm going to go up by 3. So I'm going to add 3 to my y. And then I graph my results. Okay. Now, my graph may look kind of odd. Now, the reason is, if you notice, my scaling is a little bit off compared to the original picture here. Okay. Now, here's the thing. Okay, I know I didn't do the sketch the best I can, but idea is, if you look at this, right? Now, even though there's some change in the movement, it's still the exact same shape. Okay, and this is something that we want to make sure. Okay, so when you're doing your transformations, when you sketch your final picture, right, it should look like your original, right? It might be flipped upside down, but the shape should always be the same, right? If I do not have this little, I don't know what you call it, but it's this little like jagged line, then I know that I did something wrong. Okay, and that's something that I need to keep in mind. Okay, so it should always be the same shape going through. Okay. So we're going to end this here. I think there should be enough examples, but if you guys have problems, feel free to send me an email. Okay. Remember, try to do this by hand. Okay. And remember the tips that I showed you. Okay, so remember, multiplication always goes before addition, subtraction. So your flips and your stretches always goes before your shifts. Okay. Now I know your book does it slightly different. Okay, but I would say this is kind of an easier way. So you just think of it as multiplication, division goes before addition, subtraction, right? Order of operations. Okay. You can do it the book way, which is where they do the horizontal shifts first. That's fine. Okay. But make sure you just kind of follow the rules properly. Okay. Easiest thing to do is also, again, slow down and then do a little bit at a time. Okay. This is helpful too because on the midterm, let's say if you're being asked this, it's a lot better to show your work, and then if you screw up, right, then you can kind of see where you messed up versus just kind of throwing things in your graphing calculator. Okay. But other than that, I will see you guys later, and we're going to move on to section 2.6.